Any shape, yeah. Just start from inside this plot. I think my script is not perfect if you start from outside.
Okay.
What is it working? Oh, I think let's start again. Sorry. It's probably my bad. Okay, let's try again.
Be a little nicer this time.
Oh, I think something seems wrong. Let me just do it in a small window. Sorry. Can you try again? just do it over here. I think. Oh, this works much better. All right. So this is how the solution evolves. You can see the time over here, right? U, which is the A, is equal to 1. That's the coefficient on the first order derivative. There is no second order derivative. And this is how the solution as a function of x evolves. So what does the solution look like to you? How would you describe it?
Periodic?
Yeah, it's periodic, but I actually forgot to mention that for partial differential equation, you don't just need a initial condition, you also need boundary conditions, right? I mean, you need to specify what the solution is at the boundary of the domain. And here, I actually impose that the boundary condition is periodic, so that when you draw the function, I mean, there is a sharp, I just connected the beginning and end of your drawing, so that is actually periodic. Right, so it is periodic, but the question is, how does it evolve? It moves. It moves without changing shape, right? And because it's periodic, whatever exits from the right just comes in from the left. So that seems to be the behavior of this partial differential equation. And okay, so what if I change this value of 1 or this value of a from 1 to some different values? Anybody recommend what other value we try? 5? Okay, can you come and draw initial condition this time? All right, thank you. Now what does the solution do? Moves faster, right? Kind of the same, but just moves faster. So maybe the number 5 just makes the things go 5 times faster. All right, but everything else seems the same, right? Okay. Anybody want to try something else? 20, okay. Can you come and draw? Okay. All right, it's going very fast, right? Thank you. So, well, it does seems to be still moving without changing shape, but like it's too fast to really see that clearly. Who wants to try something negative? Yeah, negative pi. Okay, can somebody come and draw negative pi? All right. What do you think it'll behave? What if u is negative? Huh?
Oh, this is hard.
Huh?
Does it have to be a function, or can you draw like a circle?
It has to be a function. Yeah.
It's still going.
It's still going, but towards the left now, right? Okay. So now we have seen the behavior, and can somebody connect this in your mind to how does the solution look like in the plot of x and t, right? So if I can convert this moving picture into a contour plot in x and t, right? So the high values of u is red, the low levels of u is blue. Like how would the color look like in this plot of x and t?